Today we're going to look at factoring. In order to factor, we are going to need to have a quadratic, which means that the highest degree or the highest exponent on one of our variables is the power of 2. The first thing you always want to look for when you're factoring is a greatest common factor. So when I look at these, what I see is that they each have, in my one over here on the left, I have a 2x squared plus 4x. Each one of those I could divide by 2, and I could also divide by x. So I'm going to take and I'm going to bring the 2x out in front, and if I divide out 2x from that, 2 divided by 2 is 1, x squared divided by x is just x. And over here, 4x divided by 2x leaves me just a 2. So to factor this one, I would be able to divide out a 2x, and that would leave me in parentheses x plus 2. And if I want to double check it, I can multiply it back out and see if it works. 2x times x is 2x squared, and 2x plus 2 is 4x. All right, looking at the second one, these ones, I look at the coefficients first. I have a 3 and a 6. I can divide each one of those by 3, so I'm going to put my greatest common factor out in front. I have an x cubed and an x squared. If I have the same variable, the number or the power that goes out the side is always the lower of the two powers. So this would have an x squared, and then I've got a y squared and a y, which is just y to the first power, so I'm going to use the lower exponent. And I actually have to divide each one of these by 3x squared y. So 3 divided by 3 would be 1. X cubed divided by x squared would leave me x. Y squared divided by y leaves me y to the first power. Over here, negative 6 divided by 3 leaves me negative 2. X squared divided by x squared cancels out. Y divided by y also cancels out. So what I have, after I factor, 3x squared y times, in parentheses, xy minus 2. There are three different ways, or three different types of questions that we're going to factor. The first one, and when you're looking at these, you always want to look at how many terms there have, right? So the first one we're going to look at is binomials. Bi meaning 2, so there's 2 terms in it. Other than taking out a greatest common factor, there's only one way you can factor a binomial. First of all, there has to be a subtraction in the middle. Each one of my 2 terms has to be a perfect square. And what that means is we're going to take the square root of each one of those 2 pieces, and we're going to put a plus in one set of parentheses and a minus in the other. So we're going to take the square root of each part. So as I look at this, I have x squared minus 9. Each one's a perfect square with a minus in the middle. So I set up my 2 parentheses. Each one gets an x. Square root of x squared is x. So 1x goes to each one. The square root of 9 is 3. So each parentheses gets one of those. And I use a plus and a minus. The reason is, if I double check it with using FOIL, my first x times x is my x squared. My inners and my outers end up having opposite signs, so they cancel out. And then a positive 3 times a negative 3 makes my negative 9. Over on this second one, the first thing we want to start with is that greatest common factor again. I can take out a 4, and that's going to leave me x squared minus 4. I just keep putting that on the front, that 4 out there on the front. Then I take the square root of each one of my 2 terms, so I have an x, and in the second one I have an x. One gets a plus, one gets a minus, and the square root of 4 is 2. So to have it completely factored, I had to take this 4 and put it out front. And that's called the difference of squares. And the only way you can factor a binomial, 2 pieces, you have to have a subtraction in the middle, and each one of those has to be a perfect square after you get out your greatest common factor. All right, our next one is a trinomial, which means there's 3 pieces to it. And these ones, we want to look for a product and sum. The product that we're looking for is our coefficient on the x squared times the constant. The sum would be the b, or the coefficient on just the x term. So we're going to try a couple of these. And actually, let's start with some that have a coefficient of 1. So when I look at this, I have a 1 out in front, so I need 2 numbers that if I multiply them together make 10. So So I have a product of 1 times 10, which is 10, and a sum of 7. All right, I know the only way to make an x squared, and remember I have to have my two binomials again, the only way to make x squared is x times x. Everything, all my signs here are positive, so each one of my two binomials is going to have pluses in it. And then my two numbers that if I multiply 5 and 2 together, I get 10. They add together to make 7. So one gets a 5 and one gets a 2. It doesn't matter which one goes where. All right, moving to the second one, first thing I always look for, greatest common factor. All of those are even numbers. So I can pull out my 2. All right, I'm just going to keep attaching that, so I'm just going to focus on the part in the parentheses. So the product that I need, I take my coefficient in front of the x, which is a 1, times negative 12. So I need a product of negative 12 and a sum of negative 4. So again, I just put that out in front and then I just kind of ignore it. To make an x squared, I have an x and an x. This time, however, I have a negative in the middle and I have a negative or a minus at the end, which means to get a negative product, I need one to be positive and one to be negative. So things that I can multiply together to make negative 12, 1 and 12, but if I add those together, I'm not going to get negative 4. I can use 2 and 6, and to get a negative 4, my 6 would have to be the negative, my 2 would have to be the positive. Now these ones are a little more tricky because I do have a number out in front. Right? So the product that I'm trying to get is 18 and the sum I'm trying to get is 11. Now when I look at these, this is a little more tricky because I have to end up with a 6x squared here. So when I look at ways I can do that, I can multiply 1 and 6 and 2 and 3. But over here, the only way I can get a 3 as my last number is a 3 and a 1. Alright, everything here is positive, so I know I'm adding. So what I have to figure out is how many x's go in each one to come up with that 11 in the middle. Alright, so when I do that, if I try the 1 and the 6, and then I refoil it, right, that would give me 6x squared plus 18x plus 1, and that doesn't match. So that one doesn't work. So what we're going to try instead, we're not going to use 1 and 6, we're going to try the 2 and 3 and see if we put those in there what happens. So we're not going to use this one. 2x times 3x makes 6x squared. My inners are 9x. My outers are 2x plus 3. And when I combine those, I end up with what I'm supposed to have. 6x squared plus 11x plus 3. Alright, over on this one, start with that greatest common factor. Again, I can take out the 3. I always want to make it as small as I can. And that would leave me a 5x minus 3. Alright, so I just keep using that at the front. Now the only way that I can make 2x squared is 2x times x. And this one's pretty nice because I have a negative 3. So the only way I can do that is either 1 and negative 3 or negative 1 and positive 3. So what I have to do is figure out how to put those in there so that I end up with a positive 5. So if I put the positive 3 here and a negative 1 here, 2x squared, my outers are plus 6x, my inners are minus x, and my lasts are negative 3. And if I add those two together, that gives me my 5x. So my factored version is right here. It's just kind of like a puzzle. I just have to figure out what numbers I can put into each one of those spaces. Alright, then our last one is when we have 4 terms, and what we're going to do is we're going to do what we call factoring by grouping, which means we're splitting it into 2 pairs and then factoring each one of our pairs. So to split it into 2 groups, I have 1, 2, 3, 4 pairs. So I'm just going to split it right here, 2 and 2, and I'm going to factor these using my greatest common factor. So the greatest common factor for x squared and 4x is x, and that's going to leave me an x plus 4. And then over here, for 3xy plus 12y, my greatest common factor would be 3y, and that leaves me an x plus 4. Now if we did it right, we should end up with the exact same matching pair of parentheses. So that's one of our binomials. And once we get rid of that, the stuff that's left over on the outside is our other binomial. Okay, let's try the other one over here. Break it into our two pairs. So I can factor a 2x out of each one of those, and that leaves me an x minus y. And when I do the other one, I want to end up with the signs being the same. So if I factor out just a plain 3, my signs are backwards. So I'm going to factor out the negative 3, and that leaves me an x minus y. Again, if I did it right, my two parentheses should match. So that matching pair of parentheses is one of my two binomials. And then once I get rid of that, my other binomial is the stuff that's left over on the outside.